This is where our journey begins, at the heart of a massive coconut processing facility that never truly sleeps. The early morning air is filled with a mix of tropical scents and the distant hum of machinery warming up for another day of intense production. Trucks laden with freshly harvested coconuts begin to roll in, their cargo destined to become part of the day's processing quota. It's a sight that would overwhelm most, but for the seasoned workers here, it's just another day at the office. As we step inside the facility, the sheer scale of the operation becomes apparent. Conveyor belts stretch as far as the eye can see, ready to carry thousands upon thousands of coconuts through various stages of processing. The challenge facing this facility is monumental: how to efficiently and consistently process such vast quantities while maintaining the highest standards of quality. Workers arrive in shifts, donning their protective gear and taking their positions along the production line. There's a palpable sense of purpose in the air as everyone prepares for the day ahead. Maintenance crews perform last-minute checks on the machinery, ensuring everything is in perfect working order. Quality control specialists review the previous day's reports, setting targets for the hours to come. The facility's capacity is truly staggering. With the ability to process tens of thousands of coconuts daily, it's a testament to modern industrial engineering and agricultural innovation. Yet, despite the impressive numbers, there's no room for complacency. Each day brings its own set of production goals, carefully calculated to meet global demand while maintaining the freshness and quality of the final product. As the first batch of coconuts begins its journey along the conveyor belt, we can't help but wonder about the intricate steps that lie ahead. How will these tough, fibrous fruits be transformed into the clear, fragrant oil we're all familiar with? The anticipation builds as we prepare to witness the first crucial step in this complex process. But before we delve into the details of coconut processing, let's take a moment to appreciate the sheer volume of work that happens here. Have you ever stopped to consider just how many coconuts go into producing the oil for global consumption? The answer is astounding. On average, this facility processes over 100,000 coconuts every single day. That's millions of coconuts each month, all destined to become part of the global coconut oil supply chain. This revelation puts into perspective the monumental task faced by the workers and machines in this facility. Each coconut must be handled with care and precision, despite the high-speed nature of the production line. It's a delicate balance between quantity and quality, one that requires constant vigilance and expertise. As we stand here, watching the first coconuts of the day make their way towards the initial processing stage, we can't help but feel a sense of awe. The journey from fruit to oil is about to begin, and we're privileged to witness every step. The husking process awaits, promising to reveal the secrets hidden within each coconut's tough exterior. Join us as we follow these coconuts through their transformation, uncovering the intricate processes and dedicated individuals that make it all possible. The day has just begun, and there's so much more to discover in the world of coconut oil production. As we venture deeper into the facility, we're confronted by an awe-inspiring sight: mountains of coconuts awaiting their turn on the production line. But how do these tough, fibrous spheres become the silky oil we know? The answer lies in a process that's both an engineering marvel and a delicate balance of efficiency and precision. The journey begins with husking, a crucial step that sets the stage for the quality of the final product. Proper husking is more than just removing the outer layer. It's about preserving the integrity of the coconut kernel within. Any damage at this stage can lead to oxidation, affecting the flavor and purity of the oil. It's a delicate dance between speed and care, as workers and machines alike must process thousands of coconuts per hour without compromising quality. As we watch the husking machinery in action, it's clear that this is no simple task. Mechanical huskers, resembling large rotating drums, tumble the coconuts against abrasive surfaces. The outer husk, made up of strong fibers called coir, is gradually stripped away. It's a noisy process, with the constant thud of coconuts and the whir of machinery filling the air. But beneath the cacophony, there's a rhythm to the operation, a well-orchestrated symphony of man and machine working in harmony. The challenge here is twofold: maintaining efficiency while ensuring each coconut is properly husked. Too aggressive, and the delicate kernel inside might be damaged. Too gentle, and production slows to a crawl. It's a balancing act that requires constant monitoring and adjustment. Quality control specialists roam the line. As the husks fall away, we get our first glimpse of the coconut's inner structure. Each nut is composed of several distinct parts, each with its own potential use. The outermost layer we've just removed, the husk, is rich in fibers. Beneath that lies the hard shell, protecting the prized white kernel inside. Between the shell and the kernel is a thin brown layer called the testa. At the coconut's core, you might find coconut water, though many of the mature coconuts used for oil production have already converted this liquid into solid endosperm. Watching this process, one can't help but wonder, what happens to all those discarded husks? In a facility processing over 100,000 coconuts daily, the volume of husks is staggering. It would be easy to assume this material goes to waste, but that couldn't be further from the truth. In fact, the innovative use of coconut husks is a testament to the facility's commitment to sustainability and zero-waste practices. Coconut husks, it turns out, are incredibly versatile. The coarse fibers are processed into coir, a material used in everything from doormats and brushes. The finer dust and pith from the husks are compressed into cocoa peat, a popular growing medium for plants that retains water exceptionally well. Some of the husk material is even used as biomass fuel, helping to power the very facility that processes the coconuts. But perhaps the most surprising use of coconut husks is in the realm of water filtration. The carbonized shells and fibers create an effective activated carbon filter, capable of removing impurities from water. It's a perfect example of how every part of the coconut can be utilized, turning potential waste into valuable resources. As the newly husked coconuts continue their journey down the production line, we're left with a newfound appreciation for this initial step. What seemed like a simple process of removing an outer layer has revealed itself to be a complex operation with far-reaching implications for both product quality and sustainability. The husked coconuts now move on to the next crucial stage: cracking. Here, precision becomes even more critical as we prepare to access the heart of the coconut, the kernel that will eventually become the oil we're all familiar with. The cracking process promises to be just as fascinating, with its own set of challenges and innovations. Let's follow these coconuts as they make their way to the cracking station, where the next chapter in our coconut oil saga unfolds. The newly husked coconuts now face their most critical challenge yet. Imagine trying to crack open thousands of coconuts per hour without damaging the precious kernels inside. It's a task that requires the delicate touch of a surgeon combined with the efficiency of a factory line. Welcome to the cracking station, where precision is paramount. This stage is crucial for determining the quality and quantity of oil that can be extracted from each coconut. The goal is simple yet demanding. Split the hard shell perfectly to reveal the pristine white kernel inside, without causing any damage that could compromise the oil's purity or reduce the overall yield. The importance of this step cannot be overstated. Any nicks or bruises to the kernel can lead to oxidation, affecting the oil's flavor, aroma, and shelf life. Moreover, improper cracking can result in shell fragments mixing with the kernel, requiring additional processing and potentially reducing the final oil output. It's a delicate balance between speed and accuracy that keeps engineers and quality control specialists on their toes. Automating this process effectively has been one of the biggest challenges in coconut oil production. The natural variations in coconut size, shape, and shell thickness make it difficult for machines to achieve consistent results. Early attempts at automation often resulted in high rates of kernel damage or inefficient separation of shell and meat. However, modern technology has made significant strides in overcoming these hurdles. Today, we see specialized machinery designed specifically for coconut cracking. These machines use a combination of impact force and precision cutting to split the coconuts. As we observe the cracking line, we see coconuts being fed into a large cylindrical chamber. Inside, rapidly rotating blades strike the coconuts at carefully calculated points, causing them to split along their natural seams. The cracked coconuts then move to a separation stage where vibrating screens and air jets work in tandem to separate the kernels from the shells. It's a mesmerizing process to watch, with white kernels seeming to magically emerge from a cascade of brown shells and fragments. Despite these technological advancements, human oversight remains crucial. Skilled operators continuously monitor the machines, making real-time adjustments to account for variations in the coconut batches. Their trained eyes can spot issues that even the most advanced sensors might miss. As we delve deeper into the process, we learn some fascinating insights about coconut kernel yield. On average, a mature coconut yields about 350–400 grams of kernel, which is about 65 to 70% of its total weight. However, not all of this is usable for oil production. After accounting for moisture content and any unusable portions, the actual oil yield typically ranges from 50 to 60% of the kernel weight. This knowledge underscores the importance of maximizing efficiency at every stage, especially during cracking. Even a small improvement in kernel extraction can translate to significant increases in oil production when processing tens of thousands of coconuts daily. As we near the end of the cracking stage, our anticipation builds. How do workers ensure consistent quality across such massive volumes? The answer lies in a combination of technology and human expertise. Automated optical sorting systems use high-speed cameras and AI algorithms to inspect each kernel, flagging any that show signs of damage or contamination. But the human touch remains irreplaceable. Quality control specialists perform regular spot checks, examining samples from each batch. They assess factors like kernel color, texture, and aroma, subtle indicators that can signal potential issues in the cracking process or the quality of the coconut batch itself. With the cracking complete and the pristine white kernels separated, we've reached a pivotal moment in our coconut's journey. The transformation from tough, fibrous fruit to the source of luxurious oil is well underway, but the process is far from over. As we watch the kernels move towards the next stage, we can't help but wonder about the challenges that lie ahead in extracting the precious oil from these snow-white morsels. Our next stop promises to be equally fascinating, the heart of the production process where the actual oil extraction takes place. Get ready to witness the alchemical transformation of solid kernel into liquid gold, a process that combines ancient wisdom with cutting-edge technology. The journey of our coconut continues, and the best is yet to come. As we step into the heart of the facility, the air grows heavy with a rich, tropical aroma. This is where the real magic happens. But the path from solid kernel to liquid gold is far from straightforward. What if I told you that the method used here challenges everything we thought we knew about efficient oil extraction? The extraction room is a marvel of modern engineering, filled with gleaming stainless steel tanks and a network of pipes. It's here that the coconut kernels we've been following will finally release their prized oil. But before we dive into the specific method used in this facility, let's explore the various ways coconut oil can be extracted. Traditionally, coconut oil extraction was a labor-intensive process. In many parts of the world, it still is. The wet method involves grating fresh coconut meat, mixing it with water, and then squeezing out the liquid. This coconut milk is then left to ferment, allowing the oil to separate naturally. While this method preserves many of the coconut's natural compounds, it's time-consuming and unsuitable for large-scale production. Another traditional technique is the dry method, where coconut meat is dried to create copra, which is then pressed to extract the oil. This method is more efficient, but often results in lower quality oil due to the potential for contamination during the drying process. In contrast, modern industrial methods prioritize efficiency and consistency. The most common techniques include expeller pressing, where the kernels are mechanically squeezed under high pressure, and solvent extraction, which uses chemicals to separate the oil from the coconut meat. However, the facility we're in uses a method that combines the best of both worlds: cold pressing. This technique applies pressure to the coconut meat without the use of heat or chemicals, preserving the oil's natural flavor, aroma, and nutritional properties while still allowing for large-scale production. As we watch the process unfold, we see the coconut kernels being fed into large cylindrical machines. These cold press expellers use a powerful screw mechanism to crush and squeeze the coconut meat, forcing out the oil. The pressure inside these machines is carefully controlled to extract the maximum amount of oil without generating excessive heat that could degrade its quality. One of the key benefits of cold pressing is the retention of beneficial compounds like polyphenols and medium-chain fatty acids, which contribute to coconut oil's health benefits. Additionally, this method produces oil with a longer shelf life and a more authentic coconut flavor compared to refined oils. However, cold pressing isn't without its challenges. The yield is typically lower than methods that use heat or solvents, meaning more coconuts are needed to produce the same amount of oil. It also requires more precise control over the entire process, from the quality of the coconuts to the maintenance of the extraction equipment. Speaking of yield, the data on oil extraction efficiency is fascinating. On average, 100 kilograms of coconut kernels will yield about 62 to 68 liters of oil using the cold press method. However, this can vary based on factors like coconut variety, maturity, and even the time of year the coconuts were harvested. As we observe the extraction process, a question arises. What's the most challenging aspect of this stage? The answer, according to the facility's lead engineer, might surprise you. It's not the mechanical process itself, but rather maintaining consistent quality across massive volumes of coconuts. Every batch of coconuts is slightly different, she explains. Our biggest challenge is adjusting our process in real time to account for these variations while still meeting our quality standards. It's a delicate balance of science and intuition that even our most advanced sensors can't fully replicate. With the extraction complete, we watch as the freshly pressed coconut oil flows into collection tanks. Its color is a pale, translucent white, far from the clear liquid you might find on store shelves. That transformation is yet to come. As we prepare to move on to the refining stage, we can't help but marvel at the journey so far. From whole fruit to precious oil, each step has revealed new complexities and challenges. The refinement process promises to be equally fascinating, as we'll see how this raw extract becomes the versatile product we know and love. The coconut's journey continues, and with it, our appreciation for the science and artistry behind coconut oil production grows. The journey of our coconut oil is far from over. As we enter the refining area, a question looms. How do you transform a cloudy, aromatic liquid into the crystal-clear oil we see on store shelves? The answer lies in a delicate dance between purification and preservation, where even the slightest misstep could compromise months of careful work. Refining is a crucial step in producing high-quality coconut oil, serving two primary purposes: removing impurities and standardizing the product. The raw oil extracted from coconuts contains various compounds that can affect its taste, smell, and shelf life. These include proteins, free fatty acids, moisture, and even tiny particles of coconut meat. While some of these elements contribute to the oil's distinctive flavor and aroma, others can lead to rancidity or inconsistent quality if left unchecked. The challenge in refining coconut oil lies in striking the perfect balance between purification and preservation. On one hand, removing impurities is essential for creating a stable, long-lasting product. On the other, many of the compounds that give coconut oil its unique properties and health benefits are at risk of being stripped away during aggressive refining. It's a tightrope walk that requires precision, expertise, and state-of-the-art technology. As we observe the refining process, we see it unfold in several distinct stages. The first step is filtration, where the raw oil passes through a series of increasingly fine filters. These remove any remaining solid particles, ensuring a smooth, consistent texture. Next comes degumming, a process that removes phospholipids and other gummy substances that can cloud the oil. Following degumming, the oil undergoes neutralization. This step involves adding a carefully calculated amount of sodium hydroxide solution to neutralize free fatty acids, which can contribute to rancidity. The resulting soap stock is then separated from the oil, leaving behind a purer product. Perhaps the most visually striking part of the refining process is bleaching. Despite its name, this step doesn't involve adding any bleach. Instead, the oil is mixed with natural clay materials that absorb pigments and other impurities. As we watch, the once golden oil transforms into a pale, almost colorless liquid. The final stage of refining is deodorization. Here, the oil is subjected to high heat and vacuum conditions, which remove volatile compounds responsible for strong odors and flavors. It's a delicate process. Too much heat can destroy beneficial compounds, while too little may leave behind unwanted flavors. Throughout our tour, we've learned that not all coconuts are created equal. The variety of coconut used can significantly impact the refining process. Some varieties naturally contain higher levels of certain compounds, requiring more intensive refining. Others may have a milder flavor profile, allowing for gentler processing. The facility's experts constantly adjust their techniques based on the characteristics of each batch, ensuring consistent quality regardless of the source material. As we near the end of the refining area, our curiosity grows. How does the facility ensure that every bottle of coconut oil meets the same high standards? The answer lies in a rigorous series of quality tests performed at various stages of production. These range from simple visual inspections to complex chemical analyses. One of the most critical tests is the peroxide value measurement, which indicates the oil's level of oxidation. A low peroxide value means the oil is fresh and unlikely to go rancid quickly. Other tests check for moisture content, free fatty acid levels, and even the presence of any contaminants. But perhaps the most impressive aspect of quality control is the facility's use of near-infrared spectroscopy. This advanced technology allows for rapid, non-destructive analysis of the oil's composition. By comparing the spectral data to known standards, quality control specialists can quickly identify any deviations from the desired profile. As our refined coconut oil moves towards the packaging area, we're struck by its transformation. What began as a cloudy, strongly scented liquid has become a clear, neutral-tasting oil ready for bottling. The journey from raw extract to finished product has been a testament to the precision and care involved in modern food processing. Our next stop promises to be equally fascinating as we witness how this liquid gold is packaged and prepared for its journey to consumers worldwide. The bottling process awaits, where cutting-edge technology meets stringent quality control to ensure every container of coconut oil meets the highest standards of purity and safety. While we've seen the meticulous process of refining coconut oil, the real test of quality lies ahead. As we enter the packaging area, a question emerges. How does this facility ensure that every single bottle maintains the same level of purity from production line to pantry shelf? The answer involves a fascinating blend of cutting-edge technology and time-honored quality control methods. The packaging line stretches before us, a symphony of stainless steel and precision engineering. Here, our refined coconut oil takes its final form as a consumer product. But this transformation is far more than just filling bottles. Proper packaging plays a crucial role in preserving the oil's quality and extending its shelf life. The challenges faced at this stage are significant. Maintaining absolute sterility in a high-volume bottling operation is no small feat. Any contamination, no matter how minute, could compromise thousands of bottles. It's a delicate balance between speed and safety, where even a moment's lapse in attention could have far-reaching consequences. As we watch the automated packaging process unfold, it's clear that every step has been carefully choreographed. Sterilized bottles move along the conveyor belt, passing through a series of checkpoints. First, they're flushed with inert gas to remove any potential contaminants. Then, precise nozzles fill each bottle with the exact amount of oil, ensuring consistency across the entire production run. Caps are applied and sealed with tamper-evident bands, providing an extra layer of security. But the process doesn't end there. Each bottle passes through a high-speed inspection system that checks for proper fill levels, cap placement, and label alignment. Any bottles that don't meet the exacting standards are automatically removed from the line for inspection or recycling. As we observe this intricate dance of man and machine, we learn some fascinating facts about the packaging materials used. The facility has made a conscious effort to reduce its environmental impact by using recycled and recyclable materials wherever possible. The plastic bottles, we're told, are made from peat, polyethylene terephthalate, which is not only fully recyclable, but also requires less energy to produce than other types of plastic. But what about the final quality control measures? How can consumers be sure that the bottle they pick up from the store shelf contains oil of the highest quality? The answer lies in a series of rigorous tests performed on samples from each production batch. Our guide leads us to a state-of-the-art laboratory adjacent to the packaging area. Here, skilled technicians perform a battery of tests on randomly selected bottles. They check for everything from moisture content and peroxide value to microbial contamination. One particularly interesting test involves measuring the oil's refractive index, a property that can indicate whether the oil has been adulterated or improperly refined. Perhaps most impressive is the use of gas chromatography to analyze the oil's fatty acid profile. This advanced technique can detect even the slightest variations in composition, ensuring that every bottle meets the facility's strict standards for purity and nutritional content. As our tour of the packaging area comes to an end, we're left with a newfound appreciation for the care and precision that goes into every bottle of coconut oil. From the initial filling to the final quality checks, each step is designed to deliver a product that meets the highest standards of purity and safety. But our journey through this fascinating facility isn't over yet. As the day shift winds down, we prepare for a rare glimpse into the world of night operations. What happens when the sun sets and most of the workers head home? How does this massive operation maintain its round-the-clock productivity? These questions and more await us as we transition into the next phase of our exploration, promising new insights into the 24/7 world of large-scale coconut oil production. As the sun dips below the horizon, a transformation occurs within the coconut processing facility. The bustling daytime activity gives way to a different kind of energy, one that's crucial for maintaining the delicate balance of round-the-clock production. What unseen processes unfold in the quiet hours of the night, and how do they impact the quality of coconut oil we consume? In the world of large-scale coconut oil production, the concept of a traditional workday simply doesn't exist. The facility we've been exploring operates 24 hours a day, 7 days a week, a testament to the ever-growing global demand for coconut oil. This continuous operation is not just a matter of meeting production quotas. It's a necessity born from the nature of the raw material itself. Coconuts, once harvested, have a limited window for optimal processing. Delays can lead to quality degradation, affecting everything from oil yield to flavor profile. This urgency drives the need for constant operation, ensuring that every coconut is processed at its peak freshness. As we step into the facility's night shift, the atmosphere is noticeably different. The frenetic pace of the day has given way to a more measured but no less crucial rhythm. Night shift workers face unique challenges, from disrupted sleep cycles to the psychological effects of working during hours when most of the world is at rest. Despite these challenges, the night crew plays an indispensable role in maintaining the facility's productivity. Their responsibilities are diverse, ranging from essential maintenance tasks to critical processing steps that set the stage for the next day's operations. One of the primary focuses during the night shift is equipment maintenance and cleaning. With the reduced personnel and lower processing volumes, technicians have the opportunity to perform thorough inspections and repairs on machinery that runs non-stop during peak hours. This preventive maintenance is crucial for avoiding costly breakdowns and ensuring consistent product quality. But maintenance isn't the only activity that thrives in the quiet of night. Some of the most critical processes in coconut oil production occur during these off hours. Take, for example, the cold pressing of coconut kernels. This method, which preserves the oil's natural properties, benefits from the cooler nighttime temperatures. The reduced ambient heat allows for more efficient extraction without the risk of overheating the oil. Another key nighttime operation is the preparation of coconut kernels for the next day's processing. While the day shift focuses on immediate production needs, the night crew works on drying and preparing coconut meat, ensuring a steady supply of raw material for the morning shift. This preparation involves carefully controlling moisture levels and storage conditions to maintain optimal quality. Quality control also takes on a different dimension during the night shift. With fewer distractions, lab technicians can perform more in-depth analyses on samples from the day's production. These comprehensive tests often require extended processing times, making the quieter night hours ideal for such detailed work. Perhaps one of the most fascinating aspects of the night operations is the role it plays in sustainability efforts. The facility uses this time to process coconut byproducts, turning what might be considered waste into valuable resources. Husks are processed into coir fiber, shells are carbonized for activated charcoal production, and even the wastewater from oil extraction is treated for reuse or safe disposal. As dawn approaches, the night shift's efforts culminate in a flurry of activity preparing for the day ahead. Production lines are primed, raw materials are staged, and the first batches of coconuts are readied for processing. It's a seamless handover that ensures not a moment is lost in the continuous cycle of coconut oil production. The 24/7 nature of this facility is a testament to the complex demands of modern food production. It's a delicate balance of human expertise and technological precision, working in harmony to transform humble coconuts into a global commodity. As we conclude our nighttime exploration, we're left with a profound appreciation for the unseen efforts that go into every bottle of coconut oil. But our journey isn't over yet. As the facility awakens to another day of production, we turn our attention to a critical aspect of its operation: sustainability. How does a facility of this scale minimize its environmental impact while maximizing the use of every part of the coconut? The answer promises to reveal innovative practices that are reshaping the future of food processing. You might think that after extracting oil, the rest of the coconut becomes waste. Think again. In this facility, every part of the coconut has a purpose, from husk to water. What innovative solutions have they developed to ensure nothing goes to waste? And how might these practices reshape our understanding of sustainable food production? As we explore the facility's commitment to sustainability, it becomes clear that this isn't just about being environmentally friendly, it's a cornerstone of their business model. The economic and environmental benefits of utilizing every part of the coconut are substantial. By finding value in what was once considered waste, the facility not only reduces its environmental footprint, but also increases its profitability. However, the challenge of finding practical uses for all coconut byproducts is significant. Each coconut produces a variety of materials, each with its own unique properties and potential applications. The husk, shell, water, and even the residue from oil extraction all need to be accounted for. It's a puzzle that requires creativity, innovation, and often collaboration with other industries. One of the most impressive innovations we encounter is the use of coconut husks in erosion control and soil stabilization. The coarse fibers, known as coir, are woven into mats and logs that can be used in landscaping and civil engineering projects. These biodegradable alternatives to synthetic materials are not only effective, but also contribute to carbon sequestration as they decompose. The hard coconut shells, once seen as a nuisance, have found new life as activated carbon. Through a process of carbonization and activation, these shells are transformed into a highly porous material used in water filtration systems, air purifiers, and even cosmetic products. It's a perfect example of turning a potential waste product into a value-added material with wide-ranging applications. Even the coconut water, which is often discarded in mature coconuts used for oil production, has found a purpose. The facility has partnered with a local beverage company to process and bottle this nutritious liquid, creating an additional revenue stream while reducing waste. Perhaps the most surprising use of coconut byproducts is in the realm of renewable energy. The facility has implemented a biomass power plant that uses coconut shells and other organic waste to generate electricity. This not only provides a sustainable energy source for the facility, but also reduces its reliance on fossil fuels. The data on waste reduction achieved through these practices is impressive. According to the facility's sustainability report, they've managed to reduce their waste output by over 95% in the past 5 years. This translates to thousands of tons of material diverted from landfills and instead transformed into useful products. As we near the end of our tour, we can't help but wonder about the future of coconut processing. What other innovations might be on the horizon? Could coconut byproducts play a role in developing new biodegradable plastics? Or perhaps in creating sustainable building materials? The possibilities seem endless, and it's clear that this facility is at the forefront of exploring these potential applications. Of all the innovative uses we've seen, perhaps the most surprising is the development of a coconut-based fabric. By processing the fibers from coconut husks, researchers at the facility have created a soft, durable material that could potentially replace synthetic fabrics in some applications. It's a perfect example of how thinking outside the box can lead to groundbreaking solutions in sustainable manufacturing. As we prepare to conclude our 24-hour journey through this remarkable facility, we're left with a profound appreciation for the complexity and ingenuity involved in modern coconut processing, from the initial husking to the final packaging. And now, through these innovative sustainability practices, every step has revealed new depths to what once seemed a simple process. The story of coconut oil production is far more than just extracting liquid from fruit. It's a testament to human innovation and our potential to create sustainable, efficient systems that benefit both industry and the environment. As our 24-hour journey through the coconut oil facility comes to an end, we've witnessed the remarkable transformation of a humble fruit into a versatile product. From the early morning husking to the precision of oil extraction and the innovative sustainability practices, every step revealed the complexity behind this everyday item. The sheer scale of production, processing over 100,000 coconuts daily, is matched only by the meticulous attention to quality at each stage. We've seen how cutting-edge technology works hand in hand with human expertise to ensure consistent results. Next time you reach for a bottle of coconut oil, take a moment to appreciate the intricate processes and dedicated individuals behind it. From dawn to dusk and through the night, this 24/7 operation stands as a testament to modern food production's challenges and triumphs.